In this video, we're going to look at how to find the exact value of something like cosine of 165 degrees. And we want to use a half angle formula. Keep in mind, this is not your typical angle here. If you have something like this, here's your reference triangle for the 30-60 right triangle. So this angle right here is 90 degrees. So using this reference triangle, obviously you can find the sine of 30 degrees. Sine of 30 degrees is the opposite over the hypotenuse, so that's going to be 1/2. Over the cosine at 30 degrees is the adjacent over the hypotenuse, so that's the square root of 3/2. And over here in the other way, the sine of 60 degrees is the opposite, radical 3/2. And the cosine is the adjacent over the hypotenuse, so the cosine of 60 is 1/2. And of course, you should know that if you have any angle that has a reference angle of 30 degrees, 60 degrees, 45 degrees, you should be able to find the sine, the cosine, the tangent of those angles. So this one here is not your typical angle, cosine of 165. So if I were to draw this angle, 165 would be over here somewhere. In the second quadrant. So any point on the terminal side of that angle, the first coordinate would be, the x would be negative, and then we go up, so the y would be positive. So the sine of any angle that terminates in quadrant 2, the sine would be positive because it's going to be the y value over the r, the length from that particular terminal point, which is always positive. Whereas the cosine will be the x value, which is negative, over the r. That's the radius of whatever circle you form here. And of course, tangent would be the y over the x, so that's going to be negative. So you can determine what sine you're going to have. This angle right here is your reference angle. So if this angle is 30 degrees or 60 degrees, you can obviously refer to this triangle. Or if this is 45 degrees, again, you can refer to the 45, so this angle says 45, this is 45, this is 1, this is 1, and then this is the square root of 2. So you can find the sine of 45 degrees, for example, will be 1 opposite over hypotenuse, so that's 1 over the square root of 2, or if we rationalize that, that's the square root of 2 over 2. And obviously then, cosine is also the same thing, 1 over radical 2, which simplifies to this. So any angle that has a reference angle of 45, you can apply this concept right here. The only thing you have to determine is it positive or negative? So in this particular case then, we have the cosine of 165, and we want to find the exact value. Obviously you can take a calculator and compute this out and round it off. You get a decimal approximation, but we want an exact value. Just like here, we say the cosine of 30 degrees is adjacent over hypotenuse, square root of 3/2. That's the exact value. So for this one, it says half angle formula. So here's the formula we need. This is your formula. The one for sine of theta over 2 is basically the same thing, except this is a minus here, 1 minus the cosine. So this is going to be then plus or minus the square root of. So let's determine the sine. What is going to be the sine of cosine of 165? Well, 165, as we saw, is in quadrant 2. And in quadrant 2, the x value is negative. So we know this is going to be a minus. Had it been in quadrant 1 or quadrant 4, the x value would be positive, and that sine, this would be positive. So it's going to be plus or minus depending on what quadrant it's in. So then, according to the formula, then this should be the square root of. So it's going to be 1 plus the cosine of theta. And notice, theta, this is theta over 2. So whatever angle here, whatever angle we put here, has to be twice the angle that's over here. So 2 times 165 is 330 degrees. and that's over 2. So you want to have it so that this angle that you have right here in the inside this radical has a reference angle of 30 degrees, 60 degrees, 45 degrees, so you can find the exact value. Now you can find exact values for other angles that are quadrantal, like 90 degrees, or 0 degrees, or 180, or 270, or angles whose terminal side coincides with one of the axes, either the x or the y-axis. So using this formula, the cosine of 165 degrees would be the same thing as minus the square root of this formula, 1 plus cosine 330 over 2. So all we have to do then now, notice now, 330 has a reference angle. And this one, of course, is going to be somewhere in the 4th quadrant. So the reference angle is right here. So that's going to be 360 minus the angle, which will give us 30 degrees. So this then is going to be 1 plus, so the cosine of 330, as we looked at a while ago, is simply going to be the cosine of the reference angle, which is 30 degrees. And of course, since it's in quadrant 4, we know the x value is going to be positive there. So this should be positive. So as we saw earlier from the triangle, this is just going to be the square root of 3. Square root of 3 over 2. And then we just simplify this. This will be minus, and then we're going to multiply the denominator and the numerator by 2 to clear the fractions there in the numerator. So this is going to be 2 here. 2 times 1 will give us a 2 plus, and then these 2's will cancel here, will give us radical 3. And then the denominator will be 2 times 2 will be 4. This will be 4 here. And then, of course, we can simplify that by taking the square root of the denominator. Since it's a perfect square, the numerator we have to leave it the way it is. So this would just be minus square root of 2 plus radical 3. And of course, the square root of 4 is 2. So this is the exact value using this formula. I want to point out to you, there's other ways we could do this also. This would say it's the half angle. We could use the formula for the cosine. Cosine for the sum of 2 angles. A plus B. Up here then, we need to rewrite this as a sum of 2 angles. But we want those nice angles. So we want angles like 30 degrees, 60 degrees, 45 degrees, because we can find exact values for those. Or angles that have a reference angle of one of those. So what we can do here is write 165 as a sum of 2 angles, like I said. So this will be 135 plus 30 degrees. So obviously 135 has a reference angle of 45 degrees. So we can work with that from the reference triangle. And of course 30 degrees is one of the angles from our main reference triangle. So we can expand this using the formula. Write this as cosine of 135 times the cosine of 30 minus the sine of 135 times the sine of 30. And you'll get the answer. Now it's got to be different than this one. It's not going to look like this answer here. But it's the same. It's just a different form of the same answer. And I'm going to address that in the next video. Thanks for watching. We'll see you next time.